नमस्कार। स्टडी अप टू इन्फिनिटी में आप सब लोगों को बहुत बहुत स्वागत है।
So the first question is, what is real analysis? Now, real analysis is making with two words, real and analysis. So what does it mean of real? Obviously in mathematics, real means real number. Now which numbers are real number? From our childhood, we know that number line. So easily you can say that the numbers which lie on the number line is called real numbers. Okay. So this means which numbers lie on this line is called real number. And analysis means you have to analyze something. So here in real analysis you have to analyze the real number. Okay. So here you have to analyze real number and its properties. And step by step throughout our course you will know the many properties of real number. Okay, and we you will see that real number has so many beautiful properties. Okay, you will love it. Real number In real number there are so many beautiful properties, so you will love it. So let's give an example, a beautiful property of real numbers. Okay, so there's a very good property, very fantastic property. It's order relation. What is the property? Property is that uh, if I give you two numbers, 2 and 5, easily you can say that, sir, 2, okay, that's mean you can say that 5 less than 5 greater than 2. Okay, another one you can say that 2 less than 5. Okay, now if I give another two numbers about 9 and 10. Okay, so you can say that 9 less than 10 and 10 greater than 9. Whatever you can say that, that's mean one number either less than or greater than. If I give two number 2 and 2, so you can say this is 2 2. That means these two numbers are equal. Okay, now that's mean if I give you two real numbers, we don't know the which real numbers are. If I give you two real numbers, so easily you can say that either x less than y, or x greater than y, or x equals to y, for any two real numbers. Okay, either x less than y, or x greater than y, or x equals to y. And this property is called the order relation. So real number has this type of sweet property is called order relation. Now you can say that the order relation. Okay, does it hold for every number system or for real number? No, it holds only for real number. Let's give an example. Suppose you are familiar with the coordinate geometry. Obviously, no, from class 9 you know the coordinate geometry. And coordinate geometry there are so many points. Actually, there are two real lines, one horizontally and one vertically. That's why we name it R2. That's we name it R2. R2 means R cross R. Okay, and that's why we take the points at x coordinate, y coordinate. Suppose there are point 1 2, another point 3 and 4. So this is a number system. Okay, and how many numbers? There are infinite numbers of numbers. Now, the pointer like 1, 2, 3, 4. Now, if I give you two number 1, 2, and 3, 4, can you say that anything about these two number? Which point is bigger? Which point is smaller? So that's mean, can you say that which this point, which point is smaller, which point is bigger? Does these points are equal or not? So answer is no. You can't say that. You can't compare two points. Okay, that's mean here the order relation doesn't hold. Order relation doesn't hold. Okay, even they are not equal. We know 2 points are equal only when their x coordinate and y coordinate are equal. But here, the x coordinate, y coordinate different. That's when these 2 points are not equal. Now, check out another example. Suppose if you take another number system, complex complex number. Okay, and we denoted it by C. Okay, like this. And complex number system, if I give you two number, 2 plus 3i and 4 plus 5i, if anyone asks you which number is bigger, okay, so you can't say, because the complex number has no order relation. Okay, you can't say that which number is bigger, which number is smaller. So you can't compare them. So basically its design is that 2 plus 3i. 2 plus 3i means is x coordinate, x axis, real axis, and this is y axis. So 2 plus 3i is a point, and 4 plus 5i is this point. Again, you can't compare them. Okay, that's why complex number also don't have the order relation. Okay, so there's a very beautiful result, very beautiful property of real number. And further we will know that for only for this property, real number shows so many beautiful properties. Okay, so step by step you will know. Okay, so let's move on to the next topic. Clear? Now if you want to make a house, so you have to prepare yourself by buy some bricks, rods, and cement, and also you have to make a plan how will be your house. So similarly, before study real analysis, you have to remind your knowledge. Okay, some small knowledge. So let's remind it. Okay, by taking an example. Suppose a is equals to 1 2 3, and b is equals to 4 5 and 2. Then you know a union b is equals to 1 2 3 4 5, and you know a intersection b is equals to 2. Wow, very good. Now 1 2 3, so that's when you can say that 1 belongs to a, as 1 in the set a. That's why we say that 1 belongs to a. Now if someone asks you 4 belongs to a, 4 is there, no, that's in 4 does not belongs to a. Okay, 4 does not belongs to a, so we write in this way. And there's another sign we have to know that it's for all. Okay, it's for all sign, for all. Okay, and we denoted it by, we defined it by like this, a, oh, you can say this, yeah, this one. So at first you have to draw like this and then this. Okay, you can see the vertical angle like this, and it's called for all. And you have to know another notation, it's called there exist. There exist. Okay, we denote it by like e. Okay, like you can say that opposite of e. So this some things you have to know the before studying the reanalysis. Okay, before now before starting everything we have to know some definition. So here also we have to know some definition. So first, the first of all, we have to know this bounded above. For definition, suppose E is a subset of R. R means set of all real numbers. If there exists K belongs to R, there is means some there is means there are a real number K belongs to R, such that there exists. Its sign means Now, before starting anything, we have to know some definition. So here also we have to know some definition. So first of all, let's start with the first definition is bounded error. What is the definition? Definition is if E is a subset of R, E is subset of R, if there exists K belongs to R, this sign is there exists. If there exists K belongs to R such that we say that S dot T, S means such, T means that, such that for all for all X belongs to E, okay, X less than equals to K, then E has a bounded above and K is a bounded above. What does it mean? It means that if you take a real number E, sorry, a set, real, say a subset of real number E, if there is a k real number k, that's mean if there is a number, a real number k, such that for all x belongs to E, that's mean all the elements of E always less than k, if such k exist. Okay, you take E is a subset of R, if there exists a k such that for all x belongs to E, x less than equals to k. That's mean for all, each element of E always less than equals to k, less than or equals to k. If such case exists, we say that E has a bounded above. Okay, and k is called bounded above. E has a bounded above, E has a bounded above, and K is bounded above. Okay, K is bounded above. So let's try with an example. That E is a set minus infinity to 2. Okay, let's draw a number line 0, minus infinity, and so on. 1, 2. So you can say that the E set is all the numbers on this portion. Now, if you take any number on the right side of 2, say any number, say, chalo, 3, then you can see that mm, for all x belongs to E, each element of E always less than 3. Okay, that's when you can say that 3 is a bounded above and E has a bounded level. Clear? Now you can ask me, sir, if I take 4, what will be the 4? Yes, if you take 4, then also 4 is a bounded level. And another one say that, sir, 5, what about 5? Yes, 5 is also bounded level. That's means there are infinite number of bounded above. Okay, that's means there are infinite number of bounded above. Okay, now, so that's why there, since there are infinite number of boundary above, so we have to consider a unique one. We have to find a unique one, which will be unique. So that's why we define is sorry, minimum, minimum of all bounded above. Since there are A lot of boundary above, infinite number of boundary above. So if we take minimum of all bounded above, if we take minimum of all boundary above, then you can say that this part, and we denote it by supremum of E. If you take minimum of all boundary above, there are so many boundary above. If you take the minimum of all boundary above, you will get supremum of E. That means supreme means all the elements of E is less than that number. Uh, let's try understand with this example. Now in this example there are infinite number of boundary above. Now if you take minimum, there's this is boundary above, this number is boundary above, this number is boundary above, 3 is, there's so many. Now if you go close, then you go minimum. Okay, and you can see the number 2. 2 is the minimum of all the boundary above. Now the question is 2 is boundary above? So question is yes. Answer is yes. 2 is also boundary because in this given definition you see that uh, k k is boundary above if x less than equals to k. That's mean 2 all the numbers except 2 always less than 2, and if you say about 2, 2 equals 2. Okay, if equal property hold, that doesn't matter. Okay, that's when you can say that 2 is also boundary above. And if you take minimum of all the boundary above, you will get answer 2. That's mean you can say that supremum of E is equals to 2. Clear? Chalo. So, so as we know the bounded above, so there is another is bounded below. Bounded below. So what is the definition? If a subset E is subset of R, okay. Now, if there exists K belongs to R such that for all X belongs to E, X in that case, X less than in bounded above case, X less than equals to. So in this case, you have to write X greater than equals to K. If such K exists, we say that E has a bounded below. And K is called, K is a bounded below. That's mean all the elements of E is greater than K. It's greater than or equals to K. If such K exists, we call that X is a, sorry, E has a bounded below and K is a bounded below. So let's understand with an example. Suppose take an example 2 to infinity, close interval again, okay, 2 to infinity. Now if you want to say about this, that's mean if you again draw a number line, so 0 1 2 and so on. So 2 to infinity basically this portion. Now if you take a number, suppose here we want to take this number 0, okay. Now you can say that for all x belongs to E, x greater than equals to 0. That's mean A or E, A. That's mean A has a bounded below. Okay, and 0 is a bounded below. Okay, so similarly, if anyone asks you, sir, how many boundaries below there? The question is there are infinite number of bounded belows. So that's why for uniqueness we want to one things. That's why for uniqueness we in previous buffer bounded above we take minimum. Here we take maximum. maximum of all bounded below. If you take all the maximum of boundary below, so you will get the infimum. In the previous case you get supremum, in this case you get infimum. Infimum of a, take this cell is e, it will be easier for the theorem. So if e, that's mean infimum of e is the maximum of all bounded below. Okay, so here what will be infimum? In this case, what will be infimum? So infimum will be 2, because if you take all the bounded below and if you take the maximum of the bounded, you will get in this portion. Okay, we'll go at this portion. That's mean 2 is your bounded, 2 is the infimum of e. Clear? Very good. I hope all of you enjoy this lecture. So, in my next lecture, I will describe all many things and many properties of real number. Okay. So for today, tada. Have a nice day.